Hello everybody, welcome to another video lesson. We're going to be talking about trigonometric equations again. This time we're going to be solving trigonometric equations using basic identities. Okay, basic identities along with our algebraic manipulation. So let's take a look at what this looks like. Looking at our concept, we're working with the same conditional trigonometric equations. Okay, but this time they may require some simplification with our IDs, our identities. Okay, so here I've got in red, I've got the left-hand side of my equation. I've got 2 cosine squared minus sine of x minus 1. Okay, and we've got that equal to y equals 0, which is my blue line here. And we're seeing where are these lines intersecting and how can we kind of look at this algebraically after having seen this graphical representation. Okay, so we have 2 examples today. Let's go ahead and get started. Okay, our prompt is to find all solutions on the interval 0 to 2 pi. Okay, so I now have cosine and sine in my equation, so I need to actually rewrite this using just one trigonometric function. And we're going to do that by turning this sine squared of x into something with a cosine. Okay? We can do that using our Pythagorean ID that says sine squared plus cosine squared is equal to 1. And when I solve for sine squared of x, I get 1 minus cosine squared of x. Okay, so I'll have 2 times 1 minus cosine squared of x instead of 2 sine squared of x. And that's going to be equal to 1 minus cosine of x. Okay? Now I can go ahead and distribute my 2. So I'll have 2 minus 2 cosine squared x. And that's equal to 1 minus cosine of x. Still haven't touched the left-hand side of my equation yet, but now I'm going to add everything over to one side, okay? So I'm going to I'm going to subtract this 2 over here, and I'm going to add this 2 cosine squared x, so everything is on the left-hand side. So when I do that, I'm left with 2 cosine squared x minus cosine of x minus 1 is equal to 0, okay? Well, we've kind of seen this before, and we know we're going to have to use some sort of substitution. So I'm going to set up this variable u. U is going to be equal to cosine of x. Okay, so I'll have 2u squared minus u minus 1 is equal to 0. And that's going to factor into 2u plus 1 times u minus 1 is equal to 0. And we can go ahead and use our zero product property and bring this up here. This will be 2 cosine of x plus 1 is equal to 0. And cosine of x minus 1 is equal to 0. Okay, so I just set each of these equal to 0, and I substituted in my cosine for u again. Okay, so when I do that on this side, I'm left with cosine of x is equal to negative 1/2, and on this case I'm left with cosine of x is equal to 1. Okay, now you can take a look at your unit circle to see where cosine is equal to negative 1/2 as well as 1, and we get x values of 2 pi over 3, okay, for negative 1/2, as well as down here at 4 pi over 3. Okay, so 2 pi over 3 and 4 pi over 3. As well as, let's see, when cosine of x is equal to 1, that is at 0. Okay, at 0. Now, since 2 pi is not included in my interval, I'm not going to include 2 pi in my solution. Okay, so that would be the process there, as far as rewriting everything using just one trigonometric function. Okay, so let's go ahead and take a look at example number 2. Okay, same prompt. We have the same interval of 0 to 2 pi. Now I've got secant of x plus 1 is equal to tangent of x. Okay, so this time we're going to solve by squaring. Okay, solve by squaring. Now again, I need to rewrite some things in terms of just one trigonometric function. But first we're going to have to square in order to do so, because I know that the tangent of x squared, okay, when I look at my Pythagorean ID, I have an ID for that, right? There's nothing to switch from tangent to secant, right? But from tangent squared, I have this identity here that says this is equal to secant squared x minus 1, okay? So now I can rewrite this left-hand side as secant squared x minus 1. Let me go ahead and move this over, actually. Okay, so the left-hand or the right-hand side is going to be secant squared x minus 1, okay? So now I've got this secant x plus 1 quantity squared. So that's going to go ahead and FOIL into secant of x squared plus 2 secant x plus 1, okay? Just went ahead and FOILed out the left-hand side of my equation here because this, let's see where I can do this. This is equal to secant of x plus 1 times secant of x plus 1, okay? So then I went ahead and I FOILed that out, okay? So I've got secant x squared on each side, so those will go ahead and cancel out. And I can bring over this 1, add 1 to each side, giving me a 2 secant of x plus 2 is equal to 0, okay? And I can factor out a 2, so 2 secant x plus 1 is equal to 0. And now I can go ahead and set secant of x plus 1 equal to 0. So secant of x is going to be equal to negative 1. Okay, so now we can take a look at our unit circle. And I know that secant of x is equal to 1 over my cosine, right? Secant is 1 over my cosine. Okay, so I really just need a cosine of negative 1, right? And the only place that I have that is at pi, okay, on this interval of 0 to 2 pi, okay? Where my cosine is equal to negative 1. Sorry, it's behind the writing here, but that's at pi, okay? So that would be the solution for this example, okay? Those are the only 2 examples for this video. Good luck on your practice.